Right, so let's see how you did. So ACs like these, you'll get them quite often until we get to the test. Okay. Um, After testing 320 cell phone batteries, 11 were found to be defective. But the experimental, they have to mention experimental because it's what's actually happened, right? Of finding a defective battery. So you just go 11 over 312, right? And that gives you 3.53% if you actually were to calculate that. So that's what I would expect on a test or quiz if you had to calculate that. So we will go with this one here, right? B is the correct, closest, best answer, right? Which of the following is another way of expressing 7 out of 56? Okay. And there are a number of ways of doing that, right? 7 goes in here once, goes in here 8 times, so you know it's D. Another thing you could have done is when 7 divided by 56, which is 0.125, you write that down. And then you just try all of these, right? It's definitely not this one. It's not that one. It's definitely not 7. If you divide 1 by 8, you get 0.125. And then you know this is the one that matches without even knowing how to reduce. Okay? So D, question 2. 3 and 2,600 shipments of kitchen tiles, 70 arrived cracked, right? What's the probability that the shipment will have cracked tiles? Just gonna mention something. It could have said, what's the probability of the tiles being, what would be the opposite of cracked, right? Like of them not being defective. So you have to watch out what they're asking for, right? Because if it's not defective, you'd have to take the 70 away from that because that gives you how many were not defective, right? But in this case, they want defective. So it's this. So if you divide that, you get 2.69%. So D is the closest one there. 1 mark each, okay? Chocolate making team created 750 truffles for a wedding. They made 200 dark, and the rest were made of milk chocolate. If you were to take chocolate from a serving table, what's the probability of picking up a dark chocolate truffle? Okay. Of dark would be 200 over 750. Okay, and if you divide those, you get 26.67%. And so the closest one is B, right? So 1 to 4, 1 mark each. So put a mark out of 4 maybe for the multiple choice. Okay, so a dog breeder has a litter of Labrador Retriever puppies, and in the past, the dogs she has bred have produced 23 puppies, so that's the total. 14 are chocolate colored, and the rest yellow. The rest are yellow. Based on this information, what's the probability of the next puppy having being yellow, right? Probability of yellow, right? How many puppies are yellow? Well, we take the 23 and we subtract the chocolate colored from it over 23, right? And that gives you 9 over 23. That would be good enough, but if you wrote it as a decimal, that'd be 3913, sorry, or 39.13%. Any one of these three will do, okay? I would say if you're not too sure on rounding and decimal and whatnot, I would just stop there. Because if you do make a mistake in rounding, I would have to take off marks. Okay. Express the probability of 5, 6. So this is just 1 mark. express the probability of 5/16 as a decimal percentage and words. So if you go 5 divided by 16, you get 0.3125. You get 3125 as a percent, and you could just say 5 out of 16 in words. So I'd say this, you get 1 for this, you get half for the percent and half for words, because this is the starting point, right? And then you base the rest off of the previous. Okay, so this page is worth 7. All the way, this first page is worth 7 in total, but you do whatever you need to do, right? Question 1 is worth 1, question 2 is worth 2, right? This is the short answer section. Is saying 5/16. Okay, yes, it is. Yeah. Yeah, that's fine. Aiden, yeah. For some reason, it's not giving me a little chart. Yeah, okay. And then we have this chart, which should be a slam dunk, right? 13 divided by 900, you get 0.0144. You multiply that by 100, you get 1.44%. And then words, I'm just going to go 13 out of 900. And then we have our decimal given here. So each row is worth 1, basically. Okay. So I would say if you have more than one mistake, then you don't get the mark. Okay. If you have more than one mistake per row, don't get the mark. So here, 0.56, I'm going to start here first. It's really tight here. So we're just going to go 56 out of 100. That's it. Don't have to reduce it. Percent, you just multiply that by 100 to get 56%. And then we go 56 out of 100 there. 29%. We can go divide that by 100. And that would be 29 over 100. So 29 out of 100. 10 out of 241, I would start here. Then divide them to get, and that you will have to use 4 decimals for. And you multiply that by 100 to get 4.15%. The whole chart is worth 4. So if you nail them, 4 are 4. Okay, so the assumption is if you're going from fraction to decimal, you use 4 decimals unless it stops, right? Or before 4 decimals. If it's a 3 decimal answer, then you just write down the 3, right? All right. Next. Now we have a problem, a word problem, okay? This involves prediction. Okay, so if you go back to your notes, I did talk about predicting based on a smaller sample, right? Springfield High School is holding an election for student council. There are 968 students. That's your total. A poll was taken at random to find out who planned to vote for president, and this is your outcome. Okay, I would say right off the bat, you should figure out, if you add them all up, how many were polled, how many people were interviewed or surveyed, right? That's how many. So what's the probability that the student will vote for Miriam? So probability of Miriam is 26 out of 106. That's it. You could write it as a decimal or as a percentage. or in words if you'd like, but they don't specify, so just leave it here. Circle your answer, done. That's how you get away from, if you circle your answer and you make a mistake here, then we don't take marks off, because you're saying this is, just look at this. But if you just leave it up to us and one of them has a mistake, then we would have to take off for rounding. How many votes can Miriam expect to receive in this election? That's prediction. We take the probability of the small, right, and the small polling, and we apply that to the whole, right, to the total. So it's 26 divided by 106 times that, which should give us 237.43, but we can't have that because it's number of volts, right? So approximately 237 volts. If you went 238, that's fine. It has to be a whole number though, but technically rounding down would be better, right? So you don't quite have enough for that extra vote. What's the probability for a student to vote for Augustine? You go up there, it's 20 out of 106, which is 0.1887, which is 18.87%. And you can reduce that, right? If it's both even, you can always split it in half until you can't anymore, but not this year, okay? Because we just want to know if you know how to do probability, right? So this word problem here is worth 3 marks. I would argue that B is worth more, but for today, we're just going to keep it at 3. So the backside is also 7. Basically 4 for the chart, 3 for the problem, so out of 7. So 7 and 7 is out of 14. Put a mark out of 14 and submit it online. Even if you're in class, you submit it online. And have it all in one place. And then we'll continue.